Welcome back to my channel Math Mode. Really interesting challenge today. 3 to the power m minus 2 to the m equal to 65. How can we solve this challenge? This is a really great exponential equation, and in this video I'm going to fully explain you how can we solve this challenge, and I'm going to fully explain you about really interesting tricks, how can you solve this challenge easily and step by step. First of all, let's rewrite this challenge right here. So what do we have? We have 3 to the power m minus 2 to the power m equal to 65. Okay, here's our challenge. And what we should do at first, we should know a really interesting rule. Take a look closely. I want to raise 3 to the power m and 2 to the power m to the really interesting power, to the power 2 over 2. Take a look closely. So we have 3 to the power m. I raise this 3 to the power m to the power 2 over 2. Okay, 2 over 2, and I do the same thing with the right hand side. So 2 to the power m. So we have minus 2 to the power m. I want to raise this to the power 2 over 2, so the same power, okay, equal to 65. It changed nothing, obviously, because 2 to the power 2 over 2, this is 1, okay, so we have 3 to the power m and 2 to the m, obviously, because 2 over 2 equal to 1. But right now, let's look closely to this rule. For example, imagine if we have a to the power m raised to the power n. It is equal to a to the power m times n, obviously, yeah, because we have like a product, yeah. But in the same way, we can easily change these n and m places, yeah, and we can write it as a to the power n raised to the power m, because this is a product, so we can easily do this. And in this case, we can easily swap, obviously, because we have obviously equal sign in most places. So we can easily swap m and n, and right here, as you can see, we can easily n and m, we can easily swap places. Okay, so someone called this rule of interchange. So right now, let's use this rule in our question. So take a look closely what we have. We have m, we have 2, and we have 2. So let's try to bring this 1/2 inside these parentheses. Okay, so we have 3 to the power m over 2 raised to the power 2. Okay, if you look closely, we can easily multiply m over 2 times 2. We can easily have m. Okay, so this is absolutely the same case. Okay, but minus 2 to the power m over 2, so absolutely the same case, and raised to the power square, which is equal to 65. Okay, this is a very tricky moment right now, so I hope you understand this trick. Because if you raise m over 2 to the power 2, if you square it, so we have only m, so absolutely the same thing. But right now, if you look closely, we have like, this is, for example, this is our a, this is, for example, this is our b, and we have some situation like a square minus b square. So this is all known formula. This is our difference of squares. Okay, so let's write this expression as a and this expression as b. So what do we have right now? We have a square minus, right here we have b square equal to 65. Okay, so right now let's solve this really interesting question with a and b. Okay, so let's continue right here in this place on the top right here. Okay, so what do we have right now? A square minus b square. Everyone know about this formula. This is our school formula. So let's write it. A plus b. So right here we have a plus b times a minus b equal to 65. Okay, so we can easily write it as a product, because this is our formula. Right now, right here on the left hand side, we have a product of two values, two expressions. I don't know exactly how can you say it, values, expression, and on the right hand side we have only one value. So let's try to express this 65 as a product of two values. Okay, so we have a plus b, yeah, a plus b times a minus b equal to 65. How can we write it? As 13 times 5, I guess. Yeah, so we have 13 times 5. So right now we have one expression times another expression gives us one value times another value. So right here we can easily find our equations, because right here we have 13, this is greater than 5, so obviously a plus b is greater than a minus b. So a plus b equal to 13, yeah, and a minus b equal to 5. This is our obviously equation. So right here we have first equation, x plus y equal to, not x, we have a, yeah, so we have a plus b equal to 13, and we have a minus b, yeah, a minus b equal to 5. How can we solve this equation? Let's try to add. Yeah, right here we can easily add it. So we have 2a equal to, so we can easily cancel this b, so we have 2a, yeah, we have 2a equal to 18. So from here we have 2a equal to 18, and from here a equal to 9. This is our A. What about B? How can we find this B? We can plug in wherever we want the equation. So for example, right here. So 9 minus B equal to 5. So B equal to 4. Okay, this is our A and B. But let's go back to this substitution. So right here we have 3 to the power m over 2 equal to A, but A equal to 9. So we have 3 to the power m over 2 equal to 9, yeah? So how can we find it? We have 3 to the power m over 2 equal to 3 square, obviously, yeah? And right here we have 3, right here 3, so we should write an equation with our base, with our powers. So m over 2 equal to 2, so from here, so m over 2 equal to 2, and from here m equal to 4. You can easily check it with the b, but it doesn't matter. We will have the same m equal to 4, because we have like 2 to the power m over 2 equal to 4, 2 to the power m over 2 equal to 2 square, and we have absolutely the same power. We can easily check our solution right here real quick. So we have 3 to the 4th minus 2 to the 4th equal to 65. Is it correct or not correct? 3 to the 4, 81. 2 to the 4, we have, looks like 16, yeah? So 81 minus 16, yeah, this is 65. So absolutely correct solution. So let's write our answer. M equal to 4. This is our solution. So hope you understand this explanation. Write your suggestion, write your question down into the comment section. What do you think about this solution? What do you think is a correct answer to this challenge? And thank you for your time. See you in the next videos and have a great day.